Good evening, sir. Today I'm going to explain about the optimization techniques in our data warehousing. Now, first of all, we need to understand what is data warehousing. Okay, the data warehousing is a central repository of integrated data from one or more disparate sources. I mean, it is a repository for integrated data. Now, it stores the current data and historic data. From this, we can create analytical reports based on our current data and historical data. Now, what is the use of this optimization? Optimization is crucial due to slow queries, limited resources, and increasing data volumes. I mean, without optimization, data warehouses can become inefficient. So, we optimization is more important in our data warehousing. Okay. And now let us discuss about some of the optimization techniques in our data warehousing. First, let us discuss about indexing strategy. I mean, indexing strategy, it is used to improve the speed of data retrieval on our table. It is used to increase the speed of data retrieval on our table. I mean, it creates multiple indexes on each and every column of the table. So by this, we can improve the speed of data retrieval on the table. Now, there are different type of indices. So, one is tree, B-tree index, bitmap index, clustered versus non-clustered indexes. First, B-tree indexes are suitable for range queries and bitmap indexes are effective for low cardinality columns. Okay. Now, it is also important to choose the right indexes. I mean, the index we are choosing should be appropriate. Now, by the main criteria to choose these appropriate indexes are based on the query patterns, data cardinality, and data types. Okay, now it is also important that poorly choosing indexes may slow down your system. Okay, so we have to choose our indexes properly based on query patterns, data cardinality, and data types. We have to regularly review and adjust indexes to maintain optimal performance. So we have to choose based on query patterns, data cardinality, and we have to review and adjust indexes regularly. Okay. Okay. If we poorly choose any indexes, it will slow down our system. Next major technique, partitioning. What is partitioning? Partitioning divides the table into smaller or more manageable pieces based on the specific criteria. I mean, if we use specific criteria, it divides the table into smaller pieces. It allows us to manage the data separately for that criteria. I mean, it allows manage separate components of data and access them individually. We can individually access that data based on the specific criteria. Okay. Now let's discuss about the types of partitioning. Basically, there are so many types. Let's discuss about major types. I mean, horizontal, list, and hash partitioning. Horizontal partitioning divides the table into rows, whereas list and hash partitioning divides based on the specific values or hash functions. Okay, I mean it's simple. Horizontal divides into rows, while list and hash partitioning distribute the data based on specific value or hash functions. Benefits obviously it improves our query performance, simplifies data management, and accelerates backups. Simple. Now, another optimization technique is data aggregation and materialized use. What is data aggregation? Data aggregation involves pre-calculating and storing summary data such as total averages and counts. I mean, it stores the data which is used in the further queries. I mean, for example, totals, averages, counts. I mean, we store the data earlier, so we can use in our further query execution. So we can save our time for execution. And second is materialized use. The materialized use are pre-computed tables based on complex queries. They store the results of these queries. I mean, these complex queries, so enabling faster retrieval of aggregated data. So it stores the results of these queries, so we can enable faster retrieval of aggregated data. Now, benefits. Obviously, it improves the query performance as we are using the pre-calculated data with the data aggregation. So aggregation and material use significantly improve query performance, especially for complex analytical queries. I mean, it we for complex queries, it improves the query performance very significantly. These are essential for optimizing decision support systems. Okay. Now, next topic. Now, another important optimization technique is that query optimization and tuning. What is query optimization and tuning? Now, we should follow three basic steps in this query optimization and tuning. First, we need to understand the query execution plans, then identify the bottlenecks, then we have to rewrite the queries. First, we have to understand the query execution plan. Query execution plan is simply that the steps taken by the database to execute the query. Analyzing the plans, first we have to analyze the steps taken by the database to execute a query. Then with these plans, we have to identify the performance bottlenecks. Now, once we identify the performance bottlenecks, we use query profiling tools to pinpoint slow operations such as table scans, joins, and such. Addressing these bottlenecks can drastically improve our query performance. Okay, these bottlenecks are used to improve our query performance. Now, the final step is rewriting queries. Now we have to optimize the SQL code by avoiding insufficient constructs, choosing appropriate join types, and minimizing subqueries. We have to rewrite to increase the efficiency of the efficiency. Simply simplify. We also use it to simplify complex queries to improve readability and performance. Next, it's another. This is very simple optimization technique. It's ETL process optimization. It's ETL, but ETL, the name itself, we can observe that extraction, transformation, and loading. It follows three steps. Extraction, data transformation, and loading. Okay, first, it also involves three steps. First, let's take about ETL bottlenecks. First, it identify the slow steps in ETL process such as data extraction, transformation, and loading. Now, it's prioritize optimizes what to improve our. First, it identify the slow steps, and then prioritize, optimize these bottlenecks to improve overall ETL performance. Now, optimizing ETL. These employ techniques such as parallel processing, incremental loading, and anti-compression to optimize ETL processes. To optimize ETL processes, we use several techniques such as parallel processing, incremental loading, and data compression. And we also distribute the workload across multiple processes. Now, data quality checks files. Implement the data quality checks during the ETL to ensure the data accuracy and consistency. We also implement the data quality check so that we may ensure that the data is accuracy and consistent. Now, the data validation rules can help identify and correct errors before loading the data into warehouse. First, we have to check whether the data is accurate or consistent, and also by the validating, it helps us to correct our errors before the loading the data into the warehouse. Now, what is the key takeaways and future trends? In summary, the optimizing data warehousing requires combination of indexing, partitioning, aggregation, query, tuning, and ETL process improvements. Regular monitoring and maintenance are essential for sustained performance. We observed several optimization techniques such as indexing, partitioning, aggregation, query tuning, ETL process improvements, regular. So these all are we have observed. Now, what is the future trends? Now, future trends. Mainly the future trends in data warehousing optimization include, cloud-based solution and AI-powered optimization tools. It's very familiar that future trends of this data warehousing optimization include cloud-based solutions and AI-powered automated solution. These technologies promise to further automate and enhance data warehouse performance. These technologies helps us to improve and enhance data warehouse performance. So this is the brief introduction, brief explanation about our data optimization techniques in our data warehousing. Okay, thank you, sir.